Okay, ladies and gentlemen, we are back in this video with some unit circle tricks. Observe that I have a 30-degree triangle over here, 30, and that makes this 90 degrees, and of course that is 60 over here. And then I also have a triangle representing a 60-degree angle at the unit circle. So notice, just to review what we did before, that the y value is going to be the sine. Therefore, the y here, is greater than the sine of 60 is greater than the sine of 30. The x value is the cosine. The cosine of 60 degrees is less than the cosine of 30 degrees. Now, to take these two triangles again, this is a 60-degree angle. Ooh, the 60-degree angle is over here. This leaves this to be a 30-degree angle, and this was 30 degrees. They both have the same hypotenuse. It's the unit circle, so the hypotenuse is 1. So they share a side, they have 3 identical angles. These should be congruent triangles. Let's just take a look. And we'll come over with some smartboard tricks. Flip this, and what we'll see is that indeed these two triangles are the same. Now, to flip this back again, we come up with this. Here's the main point though. Let's use these two triangles, put them on the unit circle again. And what we can see is that this side of this triangle, that is the y value for 30 degrees, the sine of 30, is really the same thing as the side of this triangle, which is the cosine of 60. So what we can say is that the sine of 60 degrees, this side over here, is really the same thing as the cosine of 30 degrees. So the sine of 60 is going to be, the sine of 30 is going to be the same thing as the cosine of 60. The cosine of 30 degrees, this side, large side over here, is the same thing as the sine of 60 degrees. We could play the same game again. Sine of 20 degrees would be the same thing as the cosine of 70 degrees. Cosine of 20 is the same thing as the sine of 70. Similarly, the sine of 80 would be the same thing as the cosine of 10 degrees. Cosine of 80 is the same thing as the sine of 10 degrees. The second trick which I want you to notice about the unit circle is this. Since the sine is the y value and the cosine is the x value, what's the largest that a sine can be? Well, geez, biggest that your x value can, your y value can be on the unit circle is going to be +1. As far as the x value goes, well, since again the unit circle has a radius of 1, the biggest your x value is going to get is +1. You could also have a sine of -1, and you could also have a cosine of -1 as well. Now, in this course, for most of the time, we're only going to be concerned about angles from 0 to 180 degrees. So angles beyond 180 degrees all the way up to 359 degrees, we're not going to be concerned with. Using the unit circle, we can easily pick out a number of values for some very common angles. So for instance, 0 degrees. Let's take a look at 0. The x value is 1, the y value is 0. So the sine of 0 degrees is 0. The cosine of 0 degrees is going to be 1. Let's try for 90 degrees. 90 degrees, there is no x value, so the cosine of 90 degrees is 0. The sine of 90 degrees is 1. And 180 degrees, again, we have no y value here, so the sine of 180 degrees is 0. And the cosine this time is an x value using the unit circle superimposed on an xy coordinate system. The x value here is going to be minus 1. Well, then we have a number of other values. We have 60 degrees, we have 45 degrees, and you can pretty much predict then that since the y value of 60 is going to be greater than the y value of 45, the sine of 60 is greater than the sine of 45. Similarly, the cosine of 45 is going to be greater than the sine of 45. So moving over to this chart, there are a number of values which I would like you to memorize. I'd like you to know the sines and cosines for 0, 30, 45, 60, and 90 degrees. 30 degrees, it turns out that this distance here, the sine is a half, while this distance for the cosine is going to be 0.866. Other values for 45, notice that the values for sine and cosine for 30 swap out with sine, cosine, and sine for 60 degrees. I'd like you to know these values as decimals, and I'd also like you to memorize these values as fractional values as well. The unit circle is a good way for us to think intuitively about angles which are greater than 90 degrees, between 90 and including 180. Again, we don't worry about the ones from 180 to 360. So we can have a pretty good understanding of the sines and cosines of these angles by knowing the sines and cosines of angles from 0 to 90. To give an example, let's take a 60-degree triangle. And I ask you to memorize that the y value for 60 degrees is going to be equal to 0.866. So the sine of 60 is 0.866. And the x value is 0.5. By knowing the 60-degree triangle, you could also figure out what a 120-degree angle would be in terms of sines and cosines. It's 120 degrees this way, but really what it is, it's like 60 degrees in disguise. So this will have the same y value for 120 as it will for 60. So that's going to be equal to 0.866. Similarly, the x value is from here to here is going to be the same as from here to here. It's going to be equal to 0.5, but except that it will be negative. So in summary, what we could say then is that the sine of 120 degrees is going to be equal to 0.866, and the cosine of 120 degrees should be equal to minus 0.5. The very last point I want to make is a cautionary note about the arcsine function. Consider this angle over here, which is a 30-degree angle, and you are asked to memorize that the sine of 30 degrees is 0.5. So supposing if we apply the arcsine function, the arcsine means, okay, give me the value of the sine and I'll tell you what the angle is. So if you plug this into your calculator, by the way, when you use your calculators, you have to be careful that you are in the degree mode. But if you plug this into your calculator, you'll find that the answer comes back as 30 degrees. But is that the only answer? If we look across, what other angle has the same y value, the same sine, as 30 degrees. It's like 30 degrees this way, but since we're noting angles from the x-axis, that's really 150 degrees. So the arc sine of 0.5 is 30 degrees and 150 degrees. Now you may wonder, do you have to worry about the arc cosine function giving you two different answers? Well, let's take an example of 60 degrees. The cosine of 60 degrees is 0.5. And it's a positive 0.5. So if we said the arc cosine of 0.5, we should come up with an answer of 60 degrees. But is there any other angle on the unit circle which also has a cosine and x value of positive 0.5? And there is one, and that's going to be from the x-axis, that'll be 300 degrees. So the arc cosine of 0.5 is 60 degrees and 300 degrees, but remember that we said that we weren't going to worry about any angles greater than 180 degrees. Similarly, you may wonder about the arctangent function. Well, let's take an angle 45 degrees. Now, 45 degrees, you know that both sides of the triangle are the same. In fact, it's 0.707, 0.707. So the tangent of 45 degrees is going to be 1, and therefore the arctangent of 1 should be equal to 45 degrees. Is there any other angle that has an arctangent equal to positive 1? Well, if we take 135 degrees over here, that wouldn't work because the opposite, the sine, is 0.707, but the adjacent, the cosine, is minus 0.707, so that gives you a tangent of minus 1. Similarly, over here at 225 degrees, we have a tangent that is equal to minus 1. It's only this angle over here where the x value is going to be minus 0.707 and the y value is going to be minus 0.707. Take the ratio of those two and you get 1. So the arctangent of 1 is equal to 45 degrees and 225 degrees. But once again, we're not going to worry about an angle that is greater than